10, Section 2, Math Analysis. We're going to be doing circles today. I'm your host, Dr. D.
There's no ego going on here.
Okay, so today we're going to be talking about circles, but circles are only the first section of what we call conic sections. So let's check out what a conic section is. All right. Okay, the reason we call these shapes conic sections is because they come from a cone. If I take a cone and I intersect it with a plane, then what I'm going to end up with is a circle. Now, if I slant that plane, then I'm going to end up with the cross section between the plane and the cone will be an ellipse, an elongated circle. And if I slant the plane even further so it only chops off one portion of it, it doesn't go all the way through the cone, then I'm going to end up with a parabola. Now, if I go straight down, then I'm going to end up with a curve that's going up and a curve that's going down, so it becomes a hyperbola. So circles, ellipses, parabolas, hyperbolas are basically just sections of a cone, otherwise known as conic sections. And notice the only difference between one and another is the angle of the plane that's intersecting the cone. You guys can see this in your book on page 623. Okay, so escape. All right. So the simplest conic section is a circle. And like I said in section 1, this is incredibly easy stuff. So here's what we have with circles, is the general equation of a circle is going to be x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. That's my general equation of a circle, where x and y are the horizontal and vertical distances. H is some value subtracted from x, or some distance in the horizontal direction from the center. And k is some distance in the vertical direction from the center. R is the radius of the circle. So, there's our circle. Now notice, this circle that I just drew is, the center is 0, 0. So the equation of this circle would be simply x squared plus y squared equals r squared, where r is the distance from the center to the outside. Now you can see how this works. It's merely the Pythagorean theorem. X squared plus y squared equals r squared. And this right here is, yeah, we'll just use this. This right here is the point x, y. Or the point r theta, as we did before last chapter. But all we're doing now is x squared plus y squared equals r squared. Now, if we move our circle away from the center, okay, there's our circle now. Well, the center of this circle is going to be some x value. So it's going to be h k. It's going to be some x value and some y value. And just like before, this distance is r. So the equation of this circle right here is going to be x minus h quantity squared plus y minus k quantity squared equals r squared. Okay, now, this is the standard form of the equation here. Now, the general form of the equation is going to be x squared plus y squared plus dx plus ey plus f. This is called the general form. Now, normally, you would think you should have A, B, C before you use D, E, and F. And you would be correct. But what we're doing in this chapter is putting everything all together. So the A, the B, and the C are going to be coming later. So you'll have a lot of fun with A, B, and C later on. Especially B. That is a major choice letter right there. So right now, though, all we have is the standard form of the circle, which would show us the center of the circle, and the radius of the circle, or the general form of the circle that, oh no, equals 0. That just burns. It occurred to me we didn't have an equation at all until we have an equal sign there. So, okay, now basically what we're going to be doing is going back and forth from standard form to general form and graphing circles. So let's check that out. So first of all, what we want to do is do some graphing of circles. So if we have a circle, where was I? Okay, write the standard form of the equation of a circle that's tangent to the x-axis has its center at 3, -2. Okay. All right, center is 3, -2, and it's tangent to the x-axis. Oh, the x-axis, not the y-axis. Okay, So if it's tangent to the x-axis, then basically that just gave me the radius. If I know the center, 3, -2, and I know that the radius, well, that I know that it's tangent to the x-axis, then I know right there that the radius equals 2. And so my circle is going to be nice, right there. Okay, so radius is 2. Now, what's the equation? Well, it's going to be x minus the 3, square it, plus y minus the -2, square it, equals r squared. Now, that's the standard form of the circle. Now, if we want the general form of the circle, all we do is distribute this. So I'm just going to go x squared minus 6x plus 9 plus y squared plus 4x plus 4 equals 4. And when I put all that together, I've got x squared minus 6x. There's a y there. X squared minus 6x plus 9 plus y squared plus 4y plus 4 equals 4. So x squared minus 6x, now I'm done with the x's. Now it's time for the y's. Plus y squared plus 4y. Now it's time for the numbers. We'll subtract the 4 over here, so we have just plus 9 equals 0. So here I have standard form, here I have general form. All right, now okay, the equation of a circle is 2x squared plus 2y squared minus 4x plus 12y minus 18 equals 0. X squared plus 2y squared minus 4x plus 12y minus 18 equals 0. All right, so what we're going to do here is get the standard form of this circle so we can graph it. It's going to be difficult to graph an equation like that without a graphing calculator. So what we're going to do here is get our x's together first. So I've got 2x squared minus 4x, then plus 2y squared plus 12y. And let's just put the 18 over on the right just for safekeeping. Okay, now we're going to factor the 2's out of the x's and the y's. So we have 2 times the quantity x squared minus 2x plus blank plus 2 times the quantity y squared plus 6y plus blank equals 18. Now, what did I just add? You might think I added a blank, but I really didn't. I added 2 times a blank. So I've got to add 2 times a blank over here. And then I added another 2 times blank number 2. Oops, 2 times blank number 2. right, what goes in the blanks now? Well, you cut the middle term in half and square it, so this becomes a 1. And you cut the middle term in half here, and you square it, and this becomes a 9. So I need a 1 here and a 9 here. All right, so time to put it together. So I've got 2 times x minus 1 quantity squared plus 2 times y plus 3 quantity squared equals 18 plus 2 plus 18, which is 38. Wait a minute. No, 18, 18, 36, 30, yeah. 38. Okay, so now what I'm going to do is divide out the 2's, and so I have x minus 1 quantity squared plus y plus 3 quantity squared equals 19. So what that tells me is my center is 1, negative 3, and my radius is the square root of 19. See if I even did that right. Yeah, that's right. So 1, negative 3 is the center, and the square root of 19, which would be 4.2. Let's see. 4.35. Okay, so we've got 1, 2, 3, 4.35 right here. 1, 2, 3, 4.35. 1, 2, 3, 4.35. And 1, 2, 3, 4.35. So yeah, we'll see how well you guys can draw circles when we get done with this. But there's our circle, radius, square root of 19, center, 1, negative 3. And so all we do is we're going to factor out the coefficient of x squared and y squared. In this case, we could just divide it out all at once, but I divided it out at the end here. But then complete the square and complete the square with the y's. Make sure you add whatever you added to the left to the right, and then factor perfect square trinomials into square of binomial, and now we have standard form. So going from general form to standard form is completing the square. Going from standard form back to general form would be just distributing your x's and y's and then combining like terms. Okay, now one more type of problem is where they give you different features of the circle. Okay, so let's see here. All right, take a look at page 628 in the homework, and let's just do number 37 together. Okay, we've got the endpoints of the diameter of a circle are at 2, 3, and negative 6, negative 5. 2, 3, and negative 6, negative 5. These are the endpoints of the diameter. Now we need to find the equation of this circle. Okay, so first thing we need is the center of the circle. So I need the midpoint of this segment. Well, that's handy, we did that in the first section. So the center of this circle is going to be the average of the x's. So negative 6 plus 2 over 2. And the average of the y's, negative 5 plus 3 over 2. So my center is going to be negative 4 over 2, which is negative 2, and negative 2 over 2, which is negative 1. So negative 2, negative 1, that looks like a reasonable center, because basically we're going 1, 2, 3, 4 spaces diagonally that way, and 1, 2, 3, 4 space diagonally that way. Okay, now, basically right now we have almost the whole equation. All we need left to get the equation is the radius. So what's the distance between negative 2, negative 1, and 2, 3? Man, that's a good thing we had that in section 1. Okay, so distance is going to be the square root of x minus x. So 2 minus negative 2 is 4. And the distance between the y's, 3 minus negative 1, square it. And so our distance is going to be 16 plus 16 is 32, which equals 4 square root of 2. Now, I actually knew that already because I just counted 4 spaces diagonally, so you know that's got to be 4 square root of 2. But that's my radius. Yeah, I called it distance, but let's actually call it the radius. Okay, so now I'm ready for my equation. So it's got to be x minus the x value of the center, square it, plus y minus the y value of the center, square it, equals the radius squared. Bam! That's it. Now, if we want it in general form, all we have to do is go x squared plus 4x plus 4 plus y squared plus 2y plus 1 equals 32. So that means x squared plus 4x plus y squared plus 2y. Now, plus 5 minus 32 is going to be minus 27 equals 0. So we've got standard form and we've got general form. That's it, game over. Have fun with these.